everyone to another episode of Nerd RX podcast, and I am your host Barkha. Today we have Marzia Pendino, and she is going to talk about MTT Assay. Welcome, Marzia, to the show.
Hi, Barka. Thank you for inviting me.
I am so happy that you could be here. So, before we go into the topic, why don't you introduce yourself to our listeners?
So I'm Marzia Pendino, as you said, and I'm a chemist pharmacist. And actually, I'm a third year PhD student in University College Dublin in Ireland. And my project is funded by IRC and Breakthrough Cancer Research, a charity based in Ireland. And my research is focused on the evaluation of the therapeutic potential of cannabinoids in uveal melanoma. So, actually, uveal melanoma is a rare cancer, but is one of the most intraocular malignancy in the adult eye. And it arises in the eye, but then is spread on the liver. So, right
Okay.
now, there is no standard of care for this patient. So it will be good to figure it out if cannabinoid could be like a potential treatment for actually this patient. The bad things that a few patient has no symptoms at all, but other one present, for example, our change of the iris color, flash of the light. So it's important that they take care about this and they check with the ophthalmologist as soon as they can.
Well, thank you so much for that introduction. And you have an amazing background with chemist and pharmacist, and now
Yeah.
research. I am also a pharmacist and then a chemist and now a researcher. Well,
Good.
so
So
we
we have
have that.
something
Yeah,
common. Yeah.
yeah, we do. So let's talk about MTT assay and why did you pick this topic and what got you interested in it?
So as a researcher, and as a cancer researcher, so what I did is try to figure it out which will be the best assay for starting and to have like a drug screening, a great drug screening for my project. So and I picked up this MTT assay that is used to measure like the cellular metabolic activity as an indicator of the cell viability. So it's a simple colorimetric assay that is based in the reduction of yellow tetrazoleum salt to a purple formazan crystals by, of course, the metabolic active cells. So what happened is that the viable cells contain oxidoreductase enzyme,
Hmm.
which reduce the MTT to the formazan crystal.
Okay.
So it's actually really simple to conduct.
Hmm.
And what you can see is that you have a change of color in the plate. So briefly, it's really simple. So any researcher, even the new researcher, can perform this assay. So
Hmm.
you need to use a 96 well plate, and you can see the cells in the well, and then you need to treat the cells with the drug treatment that you wish to use, and after the time treatment that you decide to pick up, that could be 4 hour, 24 hour, 96 hour, based on different projects actually. You can then perform the MTT assay that consists in actually remove the drug treatment and then add this MTT solution for maximum 4 hours. Some of the researchers use this for like 2 hour and a half. And then after that, you can see the formats and crystals. They are like purple.
Okay.
Of course, you need to solubilize these crystals, and we usually use DMSO. and then you can read the plate in the spectrophotometers at a specific nanometer that could be between 500 and 600 actually. But by your eye you can actually see different color of the well. Of course, the viable cells will have a really strong purple color. The non-viable cells will be more fainted, really close to the yellow-like color.
Yellow.
Yeah.
Okay. So is it like concentration dependent of
No, is the it depends of the viability of the cells,
okay,
because the viable cells will have these oxyreductase enzymes, active cells that will
right.
show like the results.
Okay, so for example, I have a drug and I know this works against cancer cells that I can use in different concentrations, right? To check with the MTT assay to see the cell viability and get a dose response curve.
Yes, it's actually what you have to do. So you can
Okay.
treat the cells with different concentration, and then you will check which is the concentration of the drug that statistically reduce the cell viability of the
Okay.
cells. Of course, you don't want completely the cells dead, otherwise you
Yeah.
cannot see any results. But
Hmm.
your aim is find a concentration that will impact the viability, but
Hmm.
will not kill the cells totally.
Correct. Okay. Okay. Got it. So, how long does it take the entire experiment from start to finish?
It really depends of the time point where do you want to check the viability. So for me, I use, for example, 96 hour of treatment. So everything is based on your time treatment. But
Okay.
the MTT assay per se, it lasts from 3 to 4 hours. 4 hours, but you don't need to actually work for all the
Yeah.
time because you need
Hmm.
like time of
Incubation.
incubation. Yeah,
Correct.
yeah. So you can.
So, how do you figure out that treatment time? Like you mentioned, for you it's 96, but it would be different for someone else. So, how do
Yeah,
you figure that out?
yeah, so something that you can check before is like in literature, because a few other researchers, for example, have done this same assay in the same cell line, for example, and you can note like this, or for example, they use the same treatment in a different cell line. It really depends of the disease that you are studying. If you know that there is a specific time point that you should follow, and I will always recommend to check in the literature.
Okay.
Yeah, so this is actually an assay, an in vitro assay that you can use as a starting point for doing drug screening and to have a few data about like the viability of the cells. In particular for me, they are cancer cells. But something that I'm doing right now is something related with the tumor patient sample. So I was starting with 2D cells, and now I'm moving to 3D type of experiment.
Wow.
So yeah, so actually what I'm doing is I'm receiving biopsy. So when I talk about tumor patient sample are actually a biopsy. So they are part removed as part of a scheduled surgical removal from a patient that has this tumor, and it will actually help me to test preclinically the drug that in vitro was already tested.
Hmm.
So I started from an in vitro assay, and now I move to a preclinical assay that will give me results more related to a patient instead of
Correct.
only cells.
Okay. So you have already taken further this assay in your
Yeah,
research.
yeah. So actually, what I'm doing is I'm receiving these samples from the hospital. So
Mm-hmm.
patient go to have normal check in the hospital, and of course, the bad point of these is that sometimes the biopsy, so the tumor is so small that they need this tumor like for normal check in the hospital. So
Mm-hmm.
sometimes we cannot really use this biopsy for our treatment, but of course they need to for further like analysis and for further like detection in the hospital. But most of the time we can get these samples, and we can what we do is we divide it in different pieces, and we place in the 6-well plate with the treatment that we want to test. Of course, as for the MTT assay, I will use a control,
Mm-hmm.
and then I will treat this piece of tumor. And that's important because actually the microenvironment in this case is one of the most important things, because since it's a tumor from a patient, there will be, as soon as I treat these samples, there will be like a lot of factor that will be released and can help me to figure it out more about the disease, about like what happened, and which are the secreton factor that are released from the tumor. Something
Okay.
that, yeah, something a bit like tricky is the fact that, of course, I need, we need ethical application for performing this experiment. Instead, with the MTT, you can actually perform the assay with no application, with no ethical application, since they are like cells. In this case, the process for be approved as in order to like collect these tumor patient samples is a bit long, especially here in Ireland. But we actually got from a few hospital like this ethical application.
Okay.
And yeah, it helped us to actually reach and reach patient and clinician, and because we need both of them to help like researcher to create like new treatment and to study the disease. I mean,
Yeah.
that's something we aim all the time.
Yeah. So, is there are there any, like when we talk about MTT and cell viability assay, are there any alternative techniques to MTT to get the same results?
Um, there are other like assay that you can
Mm-hmm.
use, but there is something that you can use also in cancer cells, that instead of checking the viability of the cells, you can check actually the proliferation. So
Okay.
how the cells proliferate after they were treated with the, in my case, with an anti-cancer like treatment, and it's really similar to the MTT assay, but
Okay.
is way easier. Because it's in you need to see the cells in a 6-well plate, and you need to treat the cells at different
Mm-hmm.
time point, and then you need to remove the treatment, but you need to leave the cells in the 6-well plate with the completed media, so with FBS or pen strap or whatever,
Mm-hmm.
for at least like a number of days. So in my case, I use, for example, 8 days, and after these 8 days, you can see that the cells are not single cells, but the cells that
Uh-huh.
survive after the treatment, they are created
Mm-hmm.
like clone. So
Mm-hmm.
they are. going together and create this small like dot on the well, and you can check by like scanning the six well plate, um, which is the amount of clone that are formed after the treatment.
Hmm. Okay, interesting. Like you're going from viability to proliferation. That is really cool.
Yeah, 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 it's really good.
And I think you mentioned this previously that these techniques are very user friendly. Anyone can quickly learn these things, right?
Yeah, that's something really important, especially if you are a new researcher. Figure it out which are the most easiest like technique that you can use, especially at the beginning. And I think
Hmm.
that these two assays are really friendly use, and it doesn't the cost is really like is not expensive at all.
Okay.
So I mean, you need to buy, of course, the 96 or the 6 well plate,
Hmm.
but I mean, you need to buy the MTT, in the case of the MTT assay, but at the end, you don't need like in like to spend a lot of money, so it's just really
That's
like
good.
easy to perform. Yeah.
Hmm. So, what are the advantages and disadvantages for MTT?
Yeah, actually, for MTT, so is an easy assay, as I mentioned before,
Hmm. Yeah.
and is actually a cheap assay, and you can have really easy results, really good results, with a non-replicate tree.
Hmm.
So that's really good. If I have to mention the disadvantages, it will be, for example, that at the beginning you need to have figure it out and test different concentration of your treatment before reaching the right reduction in viability, and the troubleshooting at the beginning of the protocol, because you need to figure it out which is the time of incubation with the MTT solution and the reading of the plate. I mean, it can happen that sometimes, based on the treatment that you are testing, you can kill the cells actually, and you have no
Hmm.
results available. But I mean, it's troubleshooting, it's
Yeah.
science, so we get
Yeah.
used with all of
Yeah.
this.
Always.
Yeah.
Yeah. I don't think you can do any experiment with at least a few failures.
No, not at all. I don't think so, honestly. But we need this to grow, yeah.
Yeah. Okay. So, my last two questions that I ask everyone is: do you have any fun fact for MTT assay?
Yeah, I mean, actually, there is something. So, since this assay show different grades of purple,
Mm-hmm.
um, the viable cells will have like strong purple. The less viable will be fainted purple of
Mm-hmm.
yellow in the case of non-viable cells.
Mm-hmm.
For that reason, a researcher called this assay like 50 shades of purple,
Oh my God.
because actually you can see by your eye the results before reading and the
Right.
spectrophotometer. Yeah.
Wow. That's really
Yeah,
funny.
it's yeah, it is.
Well, and my last question to you is, can you suggest any article or protocol related to MTT assay so that I can link that down in the description for our listeners?
Yeah, so actually, this MTT assay made for the first time by Tim Mossman,
Hmm.
and I think he published a paper on the Journal of Immunological Methods in the 83.
Oh, wow.
And yeah, the title will be Rapid Colorimetric Assay for Cellular Growth and Survival, Application to Proliferation and Cytotoxic Assay. So, and he mentioned all the in the material, in the method, the cells that he used, and the colorimetric assay that he performed with the MTT. So it's well explained, and I suggest, if you want to actually have a look at these also for how to validate the results. And I mean, it's really, really interesting.
Well, okay. Thank you so much. And with this, we are going to end today's episode. Thank you so much, Marzia, for being here
Thank
with us
you.
today.
Thank you, Barca, and see you soon.
Yeah, see you
Bye.
soon. And listeners, please tune in next week for another episode of Nerd RX podcast. And in meanwhile, if you have any suggestions for topics, or if you would like to come on this podcast and share with us something you have, please email me at barkha@nerdrxpodcast.com. And remember, it's good to be a nerd. Bye.